Hey everyone, it's me, Miss B. In today's video, we are looking at the Unit 1 Lesson 12 cumulative practice problems for geometry. So, let's start with this first question. It takes up a whole page. We are supposed to match the directed line segment with the image of polygon P being transformed by polygon Q, or being transformed to polygon Q by translation by that directed line segment. So if that sounded confusing, we're basically saying P is being translated to Q. Please pick the directed line segment that made that translation. So we need to choose corresponding points and actually connect from P to Q, and that'll kind of give us our length and our direction of our points. So I'm going to kind of choose like our top right corner on each of these. So for example, on this first one here, from P to Q, if I draw a straight line, it's about that long. That looks more like A for translation 1. We're going to say this one is translation 1. For the second one, we're going to use that same corner, the top right corner, because it just seems to stick out the most to me. You want something that's going to be obvious and not just the two closest points to each other. So this is a kind of shorter directed line segment, but it goes almost exactly horizontal as well. So to me, that one looks like D, which is this directed line segment here, V. So I'm going to say that's translation number 2 was V. And then for translation 3, you have to be a little careful on this one because we're going from P to Q. So we have to start on the blue polygon and go the other direction over to Q. So the direction matters, which means this translation 3 is actually here at C. So it's C should be directed line segment A, which is translation 3. And then we're going to double check that our directed line segment here for W actually works for P to Q on segment 4. I didn't mean that to be a little bit of a curve. I just did that not straight enough that the iPad thought it was a curve. So, yep, that looks like W to me. So we're going to match up directed line segment W with translation 4. And that is all for that question. Sometimes I also like to just label these with letters on the side. So translation 1 is choice A. This one was choice D. Translation 3 was C. And then this is B. Just in case my little arrows are a little confusing, pointing between the choices and the answers. So that's our first question. Okay, so our second question, we have to go to the back page. So we actually are drawing these. So we're drawing an image of quadrilateral ABCD when translated by directed line segment V. Label the image of A as A prime, and the image of B as B prime, and the image of C as C prime, and D as D prime. So we're just going to take all of our points here and just label them as the prime variations after we translate them. So sometimes it's a little hard to see where my directed line segment is at, but it's here. And to me, that looks like it doesn't quite go like horizontal through the endpoints of these triangles, but it does, it kind of goes down and then up 2 lengths here. So I'm counting the side length of a triangle as sort of my unit. So it goes diagonally down right and then diagonally up right. So it's 1 and then 2, which means if I follow that same pattern, say from A, if I go down diagonally 1 right and then up diagonally right 2 spaces, I should be putting A prime right here. So that is what I am going to do. And this is A prime. Okay, so we'll do the same thing with B. B is going to go down 1 and then up 2. It'll end up right there. So we'll put B prime. D is going to go down 1 and up 2. It's actually going to land right on the end point of our directed line segment here. So this will be D prime. And then for C, if we go down and then over, we're going to end up right there. So right here should be C prime. Now I'm going to connect all of these together. If it'll play nice and snap, that would be great. Oh, it doesn't really want to. But okay. We'll just go with what it's given me. And I want to check that my shape looks similar enough to what I had and is the same size and all that. And it is. And if you really want to, you can show your directed line segment in between. I'm just going to use a different color to show my directed line segment here for my translation. So I have A prime, B prime, C prime, and D prime. Looks like we are done with this question. So question 3 is just which statement is true about a translation. So let's zoom in here a little bit so it's easier to read. So A, B, C, or D. A translation takes a line to a parallel line or itself. B is that a translation takes a line to a perpendicular line. C says a translation requires a center of translation. And D says that a translation requires a line of translation. So we know that a translation requires a directed line segment. So it's not going to require a line, it's just going to require a directed line segment. And a line segment are very different. It also doesn't require a center because we just shift the whole thing. It also will not rotate anything. So it's not going to make a line perpendicular. So our only option here is A, that a translation will take a line to a parallel line or to itself. So it cannot move the line onto something that requires it to rotate. So on all of our shapes up here, these segments are all parallel. So this right here has our same slope as this piece here. And so they're parallel. So it will take a line to a parallel line or to itself. All right, let's look at question 4. For question 4, we are going to select all the points that stay in the same location after being reflected across line L. Well, line L is just the only line that's on this screen here for this question. And the only points that will stay in the same location are the ones that are on the line of reflection. So I'm going to write that note here. On line of reflection. It's not necessary to write that out in order to get the credit for this. It's just a little note to myself. So I see that those choices are C and E. So I'm going to say that C and E are the only ones who will stay in the same location. All right, we still have some more questions here, so we're going to keep going. Let's switch over to the next page and look at question 5. So lines L and M are perpendicular. Okay, cool. I've got perpendicular here. I see my right angle. They're perpendicular. A point Q has this property, so it's giving us a property. Rotating it using center P has the same, rotating it 180 degrees using the center P has the same effect as reflecting it over line M. Well, P is at the center. It's actually right here, right next to our perpendicular symbol. And if we reflect our reflection across a vertical line, and M is a vertical line. A reflection across a vertical line is only going to move things horizontally because it requires that you have a perpendicular bisector between your image and your pre-image. Or the line M is the perpendicular bisector between the pre-image and the image created by that reflection. So the only way that we can have possible locations of Q, which is what they're asking for here, and then answer this, well, the only way we can give possible locations of Q is if they actually lie on line L right here. Otherwise, rotating it around P is going to take it to the other side and move it vertically as well as horizontally. So we're going to say that this would be, you can give two possible locations, so you can draw two locations, or I'm just going to say any point on line L. So I'll give Q could be here, or it could be, we'll put another one in red, it could be here. And that would create Q prime in red there, and then the blue variation of it would be about here. I'm just estimating here for, I'm labeling these as Q1. Should be Q prime, and that would be with my mark in the other location, so it would have to be up and up. That was my bad. Did I do that with A, B, C, and D? Oh no, I labeled those correctly. Okay, but any point on line L, and then I just drew some in for an example. So do all points on the plane have this property? No. No, only the points on line L. Otherwise, it's going to move them vertically and horizontally, where the points on line L, if we rotate them or reflect them, they'll just move horizontally with a 180-degree rotation. Okay, so question 6. This tells us there is a sequence of rigid transformations that takes A to A prime, B to B prime, and C to C prime. And the same sequence takes D to D prime. So we're going to draw and label D and then show how we got it. Well, if there is a sequence of rigid transformations that takes these points to these other points, we know that means they're congruent. So D prime should have about the same space and be in the same relative location as D is to the rest of this diagram. So B and C is the segment that it's on. It's on segment BC right here, and it's about this big, which means it should be the same distance. Since this should be congruent, it's going to be the same distance away from B prime, which is what I'm using as my landmark here, D prime. So I'm going to say I put D prime on B prime, C prime. And this notation with the line above just means line segment. B prime, C prime. The same distance from B prime that D is from B. And yeah, otherwise you can just kind of indicate this yourself, but I figured I'd put a little verbal explanation here too, just in case I'm looking back at this. Maybe it's a homework quiz, and I want to know how I got it there. Okay, let's look at question 7 here at the bottom. Two distinct lines, L and M, are each perpendicular to the same line, N. What is the measure of the angle where L meets N? And what is the measure of the angle where M meets N? Well, if they're perpendicular, they're saying L is perpendicular to N, which means 90 degrees. because we're going to say perpendicular means 90. Between them. And then they're also saying M meets N. So M is not perpendicular to L. It's also perpendicular to N, and that's what we have here, M meeting N, just like L meeting N here. So this is also 90 degrees. And we don't really need to give an explanation. I just felt like I should. And that is actually it for all of lesson 12. The next part of our packet is lesson 13. So yeah, quite a few questions, but not as long of an assignment as it looked. So thanks for joining me. This is Unit 1, Lesson 12, Cumulative Practice Problems for Illustrative Math Geometry.